Hi everyone. We now move on to mechanics variable acceleration. All what we have been doing in mechanics was constant acceleration. Now we move on to variable acceleration. What that means is when the acceleration is no longer constant, it keeps on changing from one point to the other. So there's a question here. This question here says that a particle is moving in a straight line. At time t seconds, its displacement, its displacement, x meters from a fixed point O on the line is given by this function here, x equals 2t to the power of 3 minus 8t. Find the velocity of the particle when t is 3. Find the acceleration of the particle when t is 2. So let's see. A particle is moving in a straight line at time t seconds. Its displacement. So displacement x is given by 2 raised to the power of 3 minus 8t. Find the velocity. And what relationship exists between displacement and velocity? If this is displacement, the x, normally we represent it by s, but here is given to us as x, so let's take it as it is. So this is trying to tell us x, the x, the t is equals to velocity. It's normally s, but for this question we are given x. The x, the t, that is when you differentiate displacement, you get velocity. And the next question asks us to find the acceleration of the particle. Is there any relationship between velocity and acceleration? Yes. Or any relationship between displacement and acceleration? Yes, there is. If this is now our velocity, the x, the t, to find the acceleration, you further differentiate this function. So when you differentiate this function, you get the 2x dt squared. This is now equals to acceleration. This is the relationship. Don't call this the x over the t. I know some people do, but it's not a fraction. This is just a notation. The x, the t. Don't say the x over the t like a fraction. They might misunderstand you if you are doing dictation for some people. This is the square x, the t square. This is the acceleration. So as long as you are able to understand these relationships, then the question becomes straightforward. Now, they are asked to say a particle is moving a straight line at time t seconds. Its displacement, x meters from a fixed point O on the line, is given by this function. Find the velocity. So now, the displacement here, we want to differentiate this. We are going to differentiate this function, this 2x cubed minus 8t t. This one will give us the velocity if we differentiate this. If we differentiate this gives us the velocity. And what do you get? Let me write it in a neat way. We have this equation here. take it from here. We now want to differentiate the x dt, the x dt. So which means if you differentiate 2t to the power of 3, you know the formula is going to be 3 times 2 raised to the power of 3 minus 1. So you're going to be 3 times 2, which is 6, raised to the power, you reduce this by 1. So this is now going to be 2. 2 is going to remain here. So this again, this is 1 here, multiplied by 8. You reduce this by 1, it's going to be to the power of 0. Anything to the power of 0 is 1. So this is going to be minus 8. So this is what you get for the displacement or the velocity. This is now our velocity. But we are asked to find the velocity when t is 3. So at t equals to 3, we now have velocity as 6 times 3 raised to the power of 2 minus 8. This is 6 times 9 minus 8. 6 times 9, this is 54 minus 8. And this is 46 meters per second. That's the velocity asked to find. The velocity is there. Now we're asked to find the acceleration. Acceleration, you know, you do double differentiation. So now you have differentiated this once, so you go to differentiate this one more time to get the acceleration. So if you differentiate this, the x square, t square, this is going to give you 12t, because now 2 times 6 is 12, and if you 2 minus 1, it's just going to be 1. And there is nothing here. Differentiate this, you get 0. So this is what you get. And now they ask you to find the value of the acceleration, find the acceleration of the particle when t is 2 at times seconds, 2 seconds. So this is just 12 times 2, which is 24 seconds. That is the answer to this question. Thank you.